Have you ever wondered how dinosaurs survived in a world that was constantly on fire? I'm not talking about the asteroid. Not yet. I'm talking about the everyday reality for many of these incredible creatures. Picture this: a world of constant volcanic eruptions, rivers of molten lava, and skies choked with ash. It sounds like a scene from a disaster movie, but for some dinosaurs, this was just home. Today, we're diving deep into a fascinating question. Could some dinosaurs have evolved to be fire? Let's set the stage. The Mesozoic Era, the age of dinosaurs, wasn't a peaceful, stable paradise. It was a time of intense geological activity. The supercontinent Pangaea was breaking apart, creating massive rift valleys and chains of volcanoes that stretched for thousands of miles. Places like the Deccan Traps in modern-day India or the Siberian Traps were volcanic provinces on a scale we can barely imagine today. These weren't single volcanoes. They were vast areas of the Earth's crust that bled lava for millions of years. For any creature living nearby, heat, fire, and toxic gases were a constant threat. So, how does life adapt to such an extreme environment? Nature is the ultimate innovator. We see it today with animals living near volcanic vents at the bottom of the ocean, or bacteria thriving in hot springs that would scald any of us. Life finds a way. This brings us to our core hypothesis. During this era of intense volcanic activity, did some dinosaurs develop specific traits to withstand the heat? Could they have evolved thick, fire-resistant skin? Let's look at the evidence. Starting with what we know about dinosaur skin. For a long time, we only had bones, so skin was a mystery. But thanks to incredible fossil discoveries, including mummified dinosaurs with skin impressions intact, we've learned a lot. We know many dinosaurs had scaly skin, similar to modern reptiles. Some had bumps and knobs called osteoderms. Think of the bony plates on an Ankylosaurus S back, or a crocodile S hide. These weren't just for show. Osteoderms provide excellent protection against predators. But could they have served another purpose? Imagine an Ankylosaurus, that famous walking tank. Its back was covered in a mosaic of bony plates embedded in its skin. This armor was incredibly tough, capable of deflecting the teeth of a Now, let's place that Ankylosaurus in a volcanically active region. That same bony armor could have doubled as a heat shield. Bone and thick, leathery skin are much better insulators than thin skin. They don't transfer heat as quickly. So, an Ankylosaurus caught near a lava flow or a blast of hot ash might have had a significantly better chance of survival than a more lightly built dinosaur. The armor that evolved for defense could have been a lifesaver against environmental hazards. 2. This isn't just a wild guess. We see similar adaptations in modern animals. The Texas horned lizard, for example, has prominent scales and horns that help it blend in and deter predators. But its thick skin also helps it survive in the scorching desert heat. While not exactly fireproof, it's a great example of skin evolving for multiple protective functions in a harsh environment. Let's take this idea a step further. What if some dinosaurs had skin that was even more specialized? While we don't have direct fossil evidence of skin with asbestos-like properties, we can look at the building blocks of life. Keratin, the protein that makes up our hair and nails, and also reptile scales, is surprisingly heat. It's a tough, fibrous protein. Is it possible that some dinosaurs evolved a skin structure with an incredibly dense, thick layer of keratin scales? This would act like a natural thermal blanket, slowing the transfer of heat to the delicate tissues underneath. Think about it like a firefighter's suit. Those suits are made of multiple layers of specialized heat-resistant materials. A dinosaur's skin could have evolved in a similar, layered way. An outer layer of thick, interlocking osteoderms and keratinous scales would deflect the initial heat, while a dense layer of tissue underneath would provide further insulation. This wouldn't make them immune to standing in lava, of course, but it could be the difference between life and death when exposed to radiant heat or falling embers from a nearby eruption. Now, let's talk about where we might find these hypothetical fire-resistant dinosaurs. The fossil record gives us clues. We find certain types of dinosaurs, like titanosaurs and other sauropods, in formations known for their volcanic activity. For instance. Fossils found within the layers of ash and lava flows of the Deccan Traps tell us that dinosaurs were living and dying in this volatile landscape right up until the final extinction event. This proximity is key. For natural selection to favor a trait like heat-resistant skin, there needs to be consistent selective pressure. In other words, the threat of fire and heat had to be a regular part of life. Dinosaurs living in a lush, stable floodplain wouldn't need it, but for those living on the slopes of an active volcanic chain, it would be a huge evolutionary advantage. The dinosaurs that, by random genetic chance, had slightly thicker or tougher skin would be more likely to survive a volcanic event, live to reproduce, pass those tough skin genes on to their offspring. Over millions of years, this could lead to a population of genuinely heat-tolerant dinosaurs. But thick skin isn't the only possible adaptation. How else could a dinosaur cope with a fiery world? Let's consider behavior. Many modern animals that live in hot climates are crepuscular or nocturnal, meaning they are most active at dawn, dusk, or at night when temperatures are cooler. Perhaps some dinosaurs in volcanic regions did the same. They might have spent the hottest parts of the day sheltered in caves, under rock overhangs, or in dense forests, emerging to forage when the risk of extreme heat was lower. They might have also had advanced respiratory systems. We know that many dinosaurs had a bird-like respiratory system with air sacs, which was incredibly efficient. This system could have helped them extract more oxygen from air that might have been thin or filled with volcanic gases. Some scientists even speculate that the large, hollow crests of dinosaurs like the Parasaurolophus could have acted as a cooling mechanism, with blood vessels near the surface radiating heat away, much like a toucan's bill or an elephant's ears. So, when we put all the pieces together, the geological evidence of a fiery world, the fossil evidence of dinosaurs living in these environments, and our knowledge of how evolution works, the idea of a fire-resistant dinosaur doesn't seem so far-fetched. It paints a picture of an animal perfectly tuned to its extreme environment, an Ankylosaurus hunkered down with its armored back facing a wave of heat from a lava flow, its body protected by a natural, built-in heat shield, or a herd of sauropods, their sheer size and thick hides offering protection as they migrate across a landscape scarred by recent eruptions. This hypothesis reminds us that dinosaurs weren't just monolithic monsters. They were a diverse and wonderfully adaptable group of animals that conquered every environment on Earth. From the polar regions to, just maybe, the very slopes of active volcanoes. They were survivors, shaped by a world of constant change and challenge. What do you think? Is it possible that some of these magnificent creatures were nature's original firefighters? Let me know your theories in the comments below. It's a fascinating area of speculation where we can really let our imaginations run wild, guided by science. Thanks so much for joining me on this journey back to the fiery age of dinosaurs. If you enjoyed this video, don't forget to hit that like button. Subscribe and ring the bell so you do unmiss our next deep dive into the mysteries of the prehistoric world. See you next time.